Next question, observation versus experiment. Where is it? There we go. There's observation and there's experiment. And I just give you an example. An observation, what's the word observation mean?
To observe something.
To observe something. You ever seen these videos of people sleeping with wires all over their head, and it's usually a night vision and they're sleeping and tossing and turning? You ever seen one of those? That, well, if you haven't, you're a failure. Anyway, that is an observation. Why? You're observing. Okay? Observational study of people and what they do in the kitchens of restaurants across America. You ever seen those videos? Makes you not want to eat out. That's observation. Well, what is an experiment? An experiment is when you actually control something in the observation. For example, let's say I split this class right down the middle, and I call the people near the window, that group, I call y'all Group A, and I call this group Group B. And I give the Group A, I give y'all a yellow peel, and I give Group B a green peel. And after about 3 weeks of taking those pills, Group A has lost like 10 pounds apiece. And Group B, y'all haven't lost any weight. Have I done an observation or an experiment? Experiment. When you control the observation, it turns into an experiment. That's all there is to it. Okay? What about a rat in a maze? I'm sorry, a mouse in a maze. What is that? Observation. You're just observing. Give them a shot of Jack Daniels, you turned it into an experiment. And watch him fall over. Well, that'd be a little nip. Mouse shot would be a little nip. Pass out. Oh gosh. I don't even cover. No, I won't cover that. I want you to know what census is. I'm not going to test you on it, but everybody should know what a census is. What is a census? It's when they come around and bug you at your house while you're watching TV. Yeah, that's what it is. They ask you how much your mom and dad make, or how much you make, and what TV shows you watch, and if you go to the gym or not, or if you eat out or not. That's what they ask you. How many kids you got? How many illegitimate kids you got? That's what they ask you. How many years? 10. Every 10 years. Now, is it important? I think it is. I think it's somewhat important. Have you seen what's happened over in China? Some of you are watching. China has cities that they have built. And guess what? People aren't living there. Okay? I don't know why. I just know that there's high-rise buildings and housing and all these cities, and nobody lives there. I mean, nobody. I mean, zilch, zero. So in some ways, I think census is important. Is census sometimes nosy? Yeah. I think it's a little bit too nosy. I think they need to curb some of their questions, but who am I? I'm just one person. So I want you to know census, not for the test, but I want you to know it just for real life. Okay, that's section 1.2. That was a long section. 1.3. What is a random sample? Let's talk about a random sample. A random sample is basically when anybody has the same chance of being picked. Example. And I give you a lot of examples so you can associate it with some of the test and homework questions that you're going to have. An example of a random sample would be taking every one of your names, first name, middle initial, and last name, putting it on a sheet of paper, no, not a sheet of paper, putting it on a sticky note. That way everybody's the same size, okay? And everybody puts their first name, middle initial, last name. Everybody's going to do the same thing. And we fold it once and we fold it twice. And we put it in a hat. Is that a random sample? Yes. Now, what would mess that up from being a random sample? If somebody folded theirs up in a different way, then yes, you could say it's not a random sample because the person drawing might pick that one instead of the other one. I don't know. If 2 or 3 people was to put their names on one Post-it note, that would not be a random sample. But it would be a simple random sample if I took a piece of notebook paper and put all your 4 names on that notebook paper. Piece of notebook paper, put all your 6 names, your 4 names by rows. And how many sheets of paper would I have? 1, 2, 3, 4, 5, 6. 6 sheets of paper, and I put those 6 sheets of paper in a hat. Would that be a simple random sample? Yes. What's the difference between a random sample and a simple random sample? Simple random sample is grouped. Simple random sample is grouped. But each group has the same what? Chance of being picked, Hubert. That's right, class. Thanks for the interaction. Y'all suck. All right, random sample, that is a test question. Dang old highlight, dang old star. Simple random sample, I don't usually ask that one, but that's the difference. It's a group. But I don't usually ask that one. Okay, we're going to talk about with and without replacement. We're going to talk about that later. We're not going to talk about that now. All right, that's 1.3. And this is what I do in probability and statistics in 103. I spend the first 2 days and we go over chapter 1 and chapter 2, which is all reading. And then we start on chapter 3, which is the math. Usually by the 3rd meeting we start on that. So this ain't my first time doing this. Stratified, I usually don't do stratified. This is where we get into the different type of samples. Let's see what they go. Stratified, systematic. I do cover systematic. Systematic random sample. There it is. It's on page 32. I'll blow it up for you. A systematic random sample is if I go through and pick every 3rd person to fail this class. 1, 2, 3, you fail. 1, 2, 3, you fail. 1, 2, 3, you fail. That's a systematic random sample. In other words, every 3rd person is picked. Every 7th person, every 25th person. If you go through the phone book and pick every last person on the right-hand side of the phone book, then that would be a systematic random sample. What is present in this sample of what? A pattern. Remember a pattern. So that's your page 32. That is a test question. A cluster sample, randomly selected collection of group individuals. The difference between a cluster and a systematic is a cluster is just I go out and grab people and put them in a group versus grouping the people on the first row, grouping the people on the second row. I've got some kind of system with a simple random sample. I don't usually test on that. Convenience. I want you to know this one because it's the least reliable. Why? Well, how biased would I be if I was a DJ at a rock station and I said I want to survey all the people listening to this station who likes rock and roll? Okay? It would be biased. Why? Because I work at a rock station. And if I sent out across the radio, okay, out there, listeners, I want to know who likes rock music. Call in right now. You think somebody's going to call in and say, I like Frank Sinatra? Why are you listening to a rock station? A convenient sample is biased because usually it is not reliable because you're lazy, pretty much. Okay, so I want you to know that convenient sample is usually the one that's not used. Here's examples of simple random and random sample. I don't like those graphics. I like the old book better on that one. And that's 1.4. .5, make sure you know what the word bias means. What does bias mean? If the results of the sample are not representative. In other words, if you take a study and you make it say whatever you want to, the chances are it's biased. It says it real, if the results of the sample are not representative of the population, it's biased. And we can bias a lot of things if we put our mind to it. Bias, make sure you know that just for the test. I'm not going to do samples, non-response. I'm not going to just read over it. That's all I want you to do. See, like this right here. This is bias. Do you think the United States should forbid public speeches against democracy? Do you think the United States should allow public speeches against democracy? Which would be a better survey question? That's interaction. I want some interaction here.
B.
B. Why?
Because you're asking us to think that they should allow it, not just like rule it out.
Exactly. With the first question, the person has a negative sense in their brain, okay? When they read the question, they think, well, heck with this. I mean, they see that negative, they see forbid. In psychology, there's a lot of words you don't want to use, and negative words you don't want to use in a survey because it's biasing the result. You get into this stuff when you get into research and you get, oh my gosh, it never ends. But that's an example of a biased question. Do you think the United States should let communist newspaper reporters from other countries come in here and send back to their papers the news as they see it? Do you think the communist countries such as Russia should let American newspaper reporters come in and send back to America the news as they see it?
A, because you're singling out Russia.
Yeah, I would say that. Yeah, you're singling out Russia. Because there's also China. And China and Russia both hate the United States. So, dislike. No, they just love us. And that's 1.5. Boy, another long section. Why don't they just put all this in one section? Good gracious, wasted paper. Okay, so we don't do 1.6? Somebody look in your...
No.
Okay? And then what do we go to chapter 2?
Yep.
That's another reading chapter probably.
2.1 to 2.3.
Thank you, ma'am. So let's go to chapter 2. Say again? Go ahead and ask. What? Did you have a question, John?
No, I just figure, I thought she said 2.1 and 2.3,
No.
and she said 2.1.
Yes, through 2.3, yeah. Descriptive statistics, let's see what we get into here. This is just like the other book, except we don't have stupid questions. Raw data. Frequency distribution. All right, let's talk about a frequency distribution. List each category of data and the number of occurrences for each category of data. Well, I think we can do better than that. A frequency distribution is a 25-cent word for head count. It's also a 25-cent word for a table or a chart. Okay? On the left-hand side, you're going to have the classes. We'll call it grades. And on the right-hand side, you're going to have the count. Or, hold your pinky up, the frequency. That's what's called in statistics, the frequency. Okay, so we've got 3 A's, 8 B's, 9 C's, 7 D's, and 2 F's. Oops. That is a frequency distribution. 25-cent word for head count. So don't let it confuse you just by hearing frequency distribution or frequency table. You can have blondes, brunettes, redheads. 12, 5, 2. Again, this is your hair color or class, and this is your head count. Frequency distributions, frequency tables, they're all the same. Class on the left, head count on the right. And that's a frequency table. Half the time you can get by with just regular definitions and statistics. Okay, there's your frequency distribution. Relative frequency. Let me ask you a question. Let me go back up here. If I wanted to ask you, what is the percentage of blondes in the class? No yawning in class. No yawning, no sneezing, no coughing. Okay? All you do is breathe in here. All right. How many blondes in the class? If I wanted a frequency or a percentage, what would it be? That means interact. I want you to interact with me. 12 out of what? Where'd you get 19?
There's 32 of us.
You got to add them up. No, I'm talking about up here. No, Jonathan. No, up here. Right here. All right. Jonathan's going to count everybody. All right. So 12, 19. So 19 is in the class, and 12 are blonde. You know what that's called in statistics? That's called relative frequency. It's a percentage. Okay? So that's the relative frequency. Don't you love it? It's all Bush's fault. bar graph. I'm going to go ahead and show you the difference between a bar graph and a histogram. You're going to love this. Bar graph. That's a bar graph. The histogram. What's the difference? Histogram, they touch each other. Bar graph, they don't. To me, that's stupid. I'm sorry. I'm take off points on the test because you didn't know the difference. I just think that's ridiculous. Just call them all bar charts, in my opinion. But I'm a redneck. All right. Make sure you know the difference between the two. I don't want you to get that wrong on the test. Okay? That's a bar chart. Bar graph. Pie charts. Now, pie charts are important. Why do you think pie charts are important? Bar charts are important too. I just make fun of bar charts and histograms because they're the same thing. All right? Bar charts are important. You need to learn how to read them. Pie charts are even more important because in any presentation or report, what's going to be in it? A pie chart. Okay? I don't care if you're talking about money and a report is telling you where the money is being spent, there's going to be a pie chart in that presentation somewhere. How do you know how to use a pie chart? Well, basically you need to know how to read percentages. If I give you a pie chart, and this is basically based on your salary, and you make whatever your salary is a month. Salary per month. And this is utilities, and that's 30%. And fuel for your car is 50%. And then we got groceries and eating out and that's also room. And this is that's utilities room. I don't know, direct TV. I don't know, whatever. All right, this is 30. Let's see, it's 50, 80, 20. So that would be 6%. 6%. 6%, 6%, that needs to be 20%, 50, 30, that's 80, 20, yeah. So this is 8%. Somebody help me out. Okay, they give you a pie chart and it looks like this, and then they tell you that you make $1,000 a month. Okay, then you multiply that 1,000 times those percentages. How much is going to be fuel? 500. Because you multiplied 50.5 times 1,000. Now I'm using 1,000 so we can do the math in our head, but if this was $1,223, you'd multiply $1,223 times 0.5, and 1,223 times 0.3, which is 300. you live in the slums. $60? You eat a lot of Roman numerals or whatever it's called. I can't even pronounce it. Roman numerals. 60 here and 80 bucks here for groceries. Okay? So you eat Roman numerals here and Roman numerals there. Your direct bill is only $60. That's a joke. Mine's like $200 a month. I watch too many movies. What time is it? Huh? Okay, Miss Kubu, what time is class over? I don't trust some of these other people.
12:35.
It's 12:17? Okay. All right, let's see what else we got left in this section. And that way I can tell y'all where to start and stop. There's a good example right there. Give yourself educational attainment. Give yourself a number and go through and do those percentages. Like 2,000 or 3,000 or 4,000 and go through and do those percentages. And that's a test question. Pie chart, test question. And that's 2.1. Two is... Oh. Yeah, we'll wait. Okay, let me go ahead and call the roll. Do not leave. Do not act like you're getting up, because that irritates me. You can pack up. Bellacomo's here, Borf is here, Brown is here, Burkett, Kane, Campbell, here. Kate, here. Casey, here. Dollarhide, here. Epps, here. Eubanks, here. Fisher, here. Grady's here, Green, as in green the color, Haynes, here. Johnson, Jonathan's here, Miss Kubu's here, Lindsay, here. Martin, here. Singleton, here. Smith, yeah. Sokolowski, Thomas, here. Walls, here. Ward, here. Jenna, yeah. Is that Jenna? Oh. Makia, here. And Vanessa just left. Woods, here. And Woolbright. Here. Okay, now, what should you be doing between now and Monday?
Studying.
Studying? Reading up to 2.1 and doing the homework for Chapter 1 and Chapter 2 in Course Compass, or whatever it's called, MyLabs Plus. Those of you that have not got into MyLabs Plus, you need to be in it by Tuesday. If you aren't, let me know Tuesday in class, and I will make some phone calls. Y'all get out of here. Have a good weekend. Whatever we covered today. I think we covered